Okay, today, adding fractions. I know so many people are scared of fractions because they've had such ugly instruction, but we're going to fix that. Because I don't do ugly instruction. Well, I guess that might depend on who you talk to. Anyway, today is adding fractions. This should be the third one you watch. If you haven't seen multiplying fractions, watch that first. If you haven't seen dividing a fraction, watch that second. This is third. Don't start here or it will seem ugly. And I don't like math ugliness. I'm a big fan of math being easy, so go ahead and start with the multiplying fractions one. Anyway, adding fractions today. It may not be as difficult as you might think. Maybe a good review or whatever. Let's just get to it. Adding fractions, no problem. Adding fractions. We have a couple of examples for you, a real-life application, but over here is the guts of it. There are two main questions. If you remember these two questions to ask them every time and remember the answers, you can walk your way through almost anything that's thrown at you as far as adding fractions goes. The first question is there a common denominator? That means, are the numbers on the bottom of the fraction the same number? That's the first thing you look for. If they are, you just add the tops, keep the denominator, because as we discussed in division and multiplication, the bottom number is kind of like the last name of a family. If a family, nobody dies or whatever, they keep having kids, all the kids have the same family name. So this, no matter how many halves we will always have halves. So if it's, or thirds or fifths, if it's like 1/5 plus 2/5, that would be 3/5. So that you just add it, and that part's easy. So first one, is there a common denominator? If so, use it, and move on. If not, if the answer is no, and we'll get to this guy here in just a second. If the answer is no, you ask yourself, does the smaller number, the smaller denominator, fit evenly into the larger denominator? In this case, it's no. If it's yes, you use the larger denominator. And then you adjust, and I'll show you how to do that. If it's not, if it won't fit evenly in, then you multiply those two and then readjust the numerators, and I'll walk you through that too here in just a second. But what is this little character here? This is the combinator. One time I was teaching this, I was really tired and it was late, it was an evening class, and I kept trying to say common denominator, but all that would come out was the combinator. So it got to be the superhero thing, combinator. And on his chest there's a plus and a minus. The combinator will save the day for adding and subtracting. Not multiplying and dividing, the denominator doesn't matter when multiplying and dividing. But for adding and subtracting, then you need the combinator to save the day. So I don't know if that'll help or it's just weird, but anyway, that's what that is. So let's get started here. So we have 9 2/3 plus 4 1/2. Here's a side note. Some people like to do it horizontally. I like this way because I like it all right in front of me where I can see it going, and you'll see why as I work through it. So first question, is there a common denominator? No. Second question, will the smaller one fit evenly inside the larger one? No. So multiply. Now there's other ways to do that, but multiplying is the quickest way. So we're just going to go here 9 because it's just going to be 9. As soon as I know there's not going to be, or there is not a common denominator, I'm going to go ahead and write all this stuff out before I even think again. So when I look common denominator, no, smaller inside the larger, no, then I immediately write this before I think again. So that when I get the answer, I can just plug it right in without having to think again. I'm a big fan of doing math without having to think too much. So we go here. 3 times 2 is 6, so I can write that on both of those already. But now I need to adjust the numerator for that. So how we do that, well, we say, well, in order to get from 2 to 6, what do we multiply it by? 2 times 3, which happened to be the other denominator because you're multiplying. So 2 times 3 is 6. Now if we do it on the bottom, we got to do it on the top. Math is a lot about balance. So 1 times 3 is 3. So that's our new numerator for that one. Over here, 3 times what is 6 times 2? 3 times 2 is 6. So if we do it on the bottom, got to do it on the top. 2 times 2 is 4. Now our fractions are proportional. They have the same numerical value, but they are now in the same family. They are now in the 6th family. So now we just follow our sign. Once we get the common denominators, we follow our sign. In this case, 4 plus 3 is 7. 7 what? 7 sixths. And then we add the column just like normally if we were adding whole numbers, and we have 13. And that's it. Except, if you notice, we have an improper fraction here. Usually we can't leave the top number of a fraction, the numerator, larger than the bottom number. So we have to change that. How do we change that? Well, before we do, realize that this 13 is going to stay the same. So it's going to be 13 plus whatever that is. So just write that down there so you don't forget your whole number is there. So, and we talked about this line means divided by. 7 divided by 6. And that's exactly how we figured that out. 7 divided by 6. So 6 will fit into 7 one time. 7 divided by 6 is 1. And there's some leftovers, right? Well, there's 1 left over out of the 7. So 7 divided by 6. 6 will fit into 7 one time. That would be 6. Plus 1 is 7. And I got ahead of myself there, and that would be sixths, because it's the same family. 1 out of the 6 we were using. So then we add those. 13 plus 1 is 14, and 1 sixth. And now we are done with that one. So in this one, you may need to listen to this several times, but I covered a lot of different things about everything that you'll need, except for this concept we'll get to here in just a second. So first question, the key to this is these two questions. 1, do you have a common denominator? If yes, use it and follow your sign. If not, ask the second question, will a smaller one fit evenly inside the larger one? If so, use that. Adjust your numerators the same way we adjusted our numerators here, and then follow your sign. If the answer is no, then you just multiply, and then adjust your numerators as we did here, and follow your sign. If you have an improper fraction here, that's okay. Just rewrite your whole number so you don't forget it, and this, you just divide. Follow the language. This means divided by. And then you get there and you combine it, and it's done. Okay, so what if you have more than 2 fractions when you're adding? Well, here we have 3. So it's the same kind of thing here. Are there common denominators? No. Will the smaller ones fit inside the larger one? Well, here's the larger one. Will both of those fit inside this one? No. So, again, you can just multiply all of them. And you will get the answer, and you'll have to reduce at the end, but it will work. The only thing I'm going to adjust a little bit is if you take the larger one and you start counting by it, it's 5, so 5, 10, 15, 20, and so on, until you get a number that both of these will fit inside of. That will save you some time with the simplification. So 5, no. 10, that'll fit in there, but that one won't. 5, 10, 15, nope, neither one. 5, 10, 15, 20. 20, that'll fit inside 20, that'll fit inside 20. So I know right away it's 20. And I should have written this first, because I know as soon as there's no common denominator, I need that. Wow. Even the equipment is getting excited about adding fractions. So I remembered it was 20. So we get into 20, 20, 20. So again, now we do the same thing we did over here. We have to adjust for our new numerators. 5 times what is 20? 10. So we have to do the same thing on the top as we do on the bottom. 5 times what? Times 4 is 20. So if we do it on the bottom, we got to do it on the top. If we do it on the bottom, times 5, we have to do it on the top. Now we have our common denominators. Now we can follow our sign. So 10 plus 12 is 22 and 27. So we have 27 20ths. But notice again, we are top heavy here. We need to adjust that. So 27 divided by 20. Well, that's going to equal 1 because 20 will fit in there one time. But we still have 7 left over. 7 left over what? 7 left over from the 20 we were using. And again, the denominator stays the same because the family stays the same. So 1 and 7 20ths. And that's it for the multiple ones. No problem. That's easy. So let's get to a practical question here. Let's say we're making patterns, or somebody's making patterns for this or that thing, and we need some material. But one pattern calls for 5 3/8 yards of a certain material, and another pattern using the same material calls for 8 1/3 yards of that material. Well, we can just go buy those chunks of material, or we can just buy one big thing and then slice it when we get home and not have to be charged for that cut. What are we going to do here? What is it going to be? Well, this is going to be addition because it's this much material and that much material put together, which is add. I don't know what the proportions are going to be, but let's say it's just that. We have this for the first one, that for the second one, but we're just going to figure out what we need to get to begin with. So again, we take 5 3/8 yards plus 8 1/3 yards. Now we ask our two questions. Again, that's the key to unlocking this. Do we have common denominators? No. Okay. Will the smaller one fit evenly inside the larger one? No. So again, before I forget, I'm going to go here. I'm going to bring my whole numbers with me so that I don't forget about them. So then I know 8 times 3 is 24. And now I have to do my adjusting. So 3 times 8, hopefully the units here don't mess you up too badly, is 24, so I have to do that on the top. 8 times 1 is 8. 8 times 4 is 24. So 3 times 4 is 12. And now we can follow our sign. We can add. 12 plus 8 is 20. 24ths. 8 plus 5 is 13. Now on here, we're not top heavy, but there is a number that can fit inside both of those. So if you remember from multiplying and dividing, it would be the cancel if you can. So here, this number here, 13, is always going to be 13. But this number here, we can fit some numbers into it. Let's say you don't know exactly the biggest number, so let's just start with 2. 20 divided by 2 is 10. 24 divided by 2 is 12. Then you notice, wait, we can do it again. Well, let's do it by 2 again. 10 divided by 2 is 5. 12 divided by 2 is 6. And now there's not a number that can go into both of those, so it's 5/6 yards. 13 and 5/6 yards. So there it is. We just follow the key. The key are the two questions. Do you have a common denominator? If so, the combinator is there. He can save the day. If not, you need to get one. Well, how do you get one? Well, will the smaller denominator fit evenly inside the larger one if it was just 2? Or the smaller ones inside the larger one if there's more than 2. If the answer is no, then you can multiply, shortcut right there. And that's it. That's adding of fractions. Hopefully not as scary as you thought it was.